Okay, the first topic in the Algebra Functions and Graphs chapter is indices. And starting off then with the rules. All of these you will have met, some in Form 3, but definitely all of them at GCSE. So first of all then, Rule 1 is the multiplication rule. And the multiplication rule says that we add the powers together. The division rule then, as you will have met in Form 3, says we subtract the powers. A power raised to another power, we multiply the powers together. A negative power will mean 1 over that base to the positive power. A fractional power with the numerator of 1 means that we want the nth root in this case. Whatever the denominator is, it is that root of the base that we need. Rule 7 then is another fractional power, and in this case the denominator again still tells us the root that we want, but the numerator now tells us the power that we must raise that to. Last rule, Rule 7 then, is the 0 power, and anything to the power of 0 will always give us an answer of 1. Okay, looking at some examples then. Example part A, first example part A. 5 to the power of 3. If you remember back, that means 5 times 5 times 5, giving us an answer of 125. Very basic to start with here. 6 to the power of 0 then in part B. If you remember, anything to the power of 0, giving us 1 as the answer. Part C then, we've got 10 to the power of minus 2, negative power telling us 1 over, so it's 1 over 10 squared with a positive power of 2. 10 squared giving us 100, so the full answer then is 1 over 100. Part D, we've got 16 to the power of minus 3/4, so we'll deal with the negative power first, giving us 1 over 16 to the power of positive 3/4. The denominator, if you remember from the rule above, tells us we want the 4th root of 16, and the numerator being 3, telling us that we must raise that all to the power of 3. So the 4th root of 16 then gives us an answer of 2, so that it'll be 2 cubed then on the denominator, and a final answer then of 1/8. Okay, part E. We have got letters as the base in this case. So again, the multiplication rule simply says we add the powers together and get a power of 6. Part F, x to the power of 9 divided by x to the power of 4. Again, division rule from the rules tells us we subtract the powers to get x to the power of 5. Part G is the power raised to a power rule, saying we're multiplying the powers together to give us x to the power of 8. H, then we've got 8x to the power of 4 divided by 2x to the power of 6. So we're going to take the numbers in front first and divide them, as it's a division question, giving us a 4. Then we'll take the power, so x to the power of 4 divided by x to the power of 6. Subtracting the powers, as the division rule says, gives us a minus 2. But simplifying that further, a negative power can be written as 1 over. So we can say that's the equivalent then of 4 times 1 over x squared, giving us then 4 over x squared as our full answer. Example 2. Okay, this time we're finding the unknown power x. So 9 to the power of x is equal to 1/3, and we're going to try and find out what that unknown power is. So first of all, we need to try and write both sides with the same base number. So 9 we know can be written as 3 squared, and 1/3 can be written as 3 to the power of minus 1, the negative power rule. Going back to the left hand side, power raised to a power here can be written as 3 to the power of 2x, multiplying them together. And because we've got the same base number now, all we have to do is equate the powers. So the power of 2x has to be equal to the power of minus 1, and that gives us a simple equation to solve. If 2x equals minus 1, x must equal minus 1/2. Part 2 then, same principles, we want the same base number. So the 4 can be written as 2 squared. Root 2 can be written as 2 to the power of a half. And again, power raised to another power, we multiply them together to get a 6x. Base numbers are the same, so we just have to equate the powers together. So 6x has to equal a half. Again, solve the equation and we get x is equal to 1/12.